In this video, I'm going to review or possibly introduce some trig functions to you. Before we get into Chapter 5 deals with forces in two dimensions, and in order to do that, we have to be able to break our vectors up into components and add the components of vectors and go from components of vectors into resultant vectors. And so in order to do all that, we need to have trig functions at our disposal. So we're going to review a little bit of these trig functions dealing with right triangles here. And if this is the first time, you may have to watch the video more than once, and that's fine. But make sure you get a basic understanding of these basic trig functions. So first, let's take a look at this right triangle. And we've dealt with right triangles like this before in that, let's say we had a length of 3 meters here and a length of 4 meters here. Well, we would know that we can find the hypotenuse by using Pythagorean theorem, say that the hypotenuse squared is just simply equal to 3 squared plus 4 squared. And if we do a little math here, we find that our hypotenuse is equal to 5 meters. Now, I'm throwing out this word hypotenuse here, and remember, the hypotenuse is always the longest side of a right triangle, and that side is always going to be opposite the right angle. And so we can do this when we're given two lengths of a right triangle. We can always find the third length using Pythagorean theorem. Now, the issue comes into play when, what if we only have one side length and an angle? And that's where the idea of these trig functions come in. And keep in mind, these trig functions only work with right triangles. They only work with right triangles. Now, the first trig function is the sine function. Now, it's pronounced sine, S-I-N-E. If you look on your calculator, if you have one of these calculators, it'll be abbreviated as just S-I-N. This button right here is the sine function button on your calculator. And in fact, it's pictured on the screen there for you. Okay, and so sine function is defined such that, say we have some angle of a right triangle, some non-90 degree angle, so one of the other two angles, the sine of that angle that we're calling theta here is going to equal the ratio of the opposite side over the hypotenuse. Okay, so it's just, that's what the function is defined as. It's defined as the ratio of the opposite side over the hypotenuse. And the calculator is programmed to know that. And so when you plug in certain angle measures and take the sine of it, it knows what that ratio is going to be automatically. Okay? So we keep this ratio that sine is of theta, sine of our angle, is equal to the opposite side over the hypotenuse. Now, why is this side called the opposite? This side is called the opposite because it's the leg that does not touch the angle. It's the leg that's opposite of the angle. There is no contact between this leg and the angle. Now, this leg of our right triangle here does touch the angle, and so therefore we call that the adjacent side. Let's take a look at an example here. Let's say we have our regular coordinate system. North is up, west is to the left, east is to the right, south is down. And we start at this position A. And we want to get to position B over here. And to do that, we travel 10 meters. Now, we're not just traveling due west, or we're not traveling due north. We're actually traveling north and west to get there, or west and north to get there. And so we say we travel at an angle, let's just use 30 degrees, and we call this angle north of west. So we are 30 degrees north of west, meaning we're opening up towards the north from the west arm here of our cardinal system here. All right, so we're moving 10 meters, 30 degrees north of west. That gives us our displacement vector. This is our displacement vector, 10 meters, 30 degrees north of west. Well, my question is, well, how far north did we travel? How far is B north of A? Not how far are they apart, but how far north is it? So we want to know, what is this distance right here? Well, that is the opposite side of our right triangle, so we can use the sine function to find it. So we know that sine of the angle, in this case our angle is 30 degrees, sine of 30 is going to equal the opposite, which we're just going to abbreviate as OPP, over our hypotenuse, which is 10 meters. Now, use a little algebra here, multiply both sides by 10, so we know our opposite side is going to be 10 times sine of 30. Now when you type this into your calculator, you can simply type in 10 sine 30 and then hit enter if you're using the calculators we use in class. If you have another calculator, I'll have to tell you how to do it in class. It may be a little different. So we find our opposite length. When we type this in, that opposite length is equal to 5 meters. Now, what is that? That's telling us that we move 5 meters north. So we've taken this vector that's moving 30 degrees north of west, and we've found its north component, and that's what we call this. This is the north component. Now, we might also call this the x component because, or excuse me, we might call this the y component because it's the vertical component, and we can call the x component when we go west and east. But either way, the vertical component, the north component, the y component, all synonymous here. So that's how far we move north. In moving our 10 meters to B, we have moved 5 meters north. Now, we might ask, well, how far did we move west? And if this is 5 meters, we can resort back to the Pythagorean theorem to find 10 squared minus 5 squared will give us our adjacent side squared. But I want to show you another trig function that will give us that same result. And that trig function is called the cosine function. And cosine, once again, can be found on your calculator if you look. It's right next to the sine function, all right, right here in the COS. And cosine is defined such that cosine of an angle is equal to the adjacent side over the hypotenuse. Once again, these ratios are always going to be the same for any given angle. All right, and the calculator has it programmed in it that it knows all of the ratios for each angle that we type in. So if we put in an angle of 10 degrees, type cosine of 10 degrees, the calculator already knows the ratio of the adjacent side over the hypotenuse side. So we can use that to find our adjacent length. So let's use that same example that we were just working with, in that here's point A, and we're going to point B, and we traveled 10 meters to go from A to B, and we did that by moving at an angle of 30 degrees north of west. But we want to know, how far west is B? We know it's 5 meters north, but how far west is it? So we can look at cosine of 30 is equal to the adjacent side here, the adjacent component of our vector, which is our horizontal component, or our west component, or our x component, whatever name you want to give it, over the hypotenuse of 10 meters. So the adjacent side is going to equal 10 times cosine of 30. Now, when you type this into your calculator, you notice you get an irrational number. Okay, cosine of 30 is actually radical 3 over 2. Now, in our class, in physics, we don't care about the radicals and writing as an exact number. We can use a decimal. It's okay. So when you type this into your calculator, you get a decimal, and you get 8.66. All right, that's fine. Leave it as 8.66. And what is that? Well, that's 8.66 meters west. So we know if we move from A to B at an angle of 30 degrees north of west, and it's 10 meters, in doing that, we have moved 8.66 meters west and 5 meters north. Okay, so that's taking a vector and breaking it into its components. Now, the last trig function we're going to look at here is tangent function. And typically, we're going to use the tangent function when our angle is unknown. Now, we do not have to exclusively use this function for that situation, but that is when we will more likely use it. Because tangent tells us that the tangent of theta is equal to the opposite leg divided by the adjacent leg. So we take this opposite leg, divide by the adjacent leg, and that's what tangent of our angle is going to be. Okay, so once again, this is on our calculator. It's that third trig function that you see on the calculator right here next to sine, cosine, then it's tangent, T-A-N. So you type in tangent of some angle, and you get the ratio of the opposite and adjacent sides for that right triangle. So let's look at an example. Let's say we're standing here and we walk, let's go 15 meters west, and that gets us to this point. And then let's walk 8 meters north, and that gets us to this point. Okay? And we want to ask, well, what angle could we have walked to just give a straight shot to that point and walk the shortest distance? So in this situation, we have the opposite side length known, we have the adjacent side length known, but we don't know the angle. Okay? Now, we could find the hypotenuse by using Pythagorean theorem, but that's not our concern here. We want to know what angle would we have to take in order to get from A to B directly. What angle would that have to be? Now, we look at that by using our tangent function. So we know tangent of theta, and we're using just this Greek letter theta to represent our angle because it's unknown. We don't know what the angle is. That's going to equal 8 meters divided by 15 meters. Now, why is it 8 over 15? Well, it's the opposite over the adjacent. And so to solve this, we have a ratio, and this is where we have to use an inverse tangent. And if you look at your calculator, right above the tangent button, you'll see a tangent raised to the -1. Now, what that means is really the correct term for it is arctangent. Okay, it should be called arctangent, but calculators want to save as much space as possible, so they just do the exponent of -1. And the arctangent is the inverse function of tangent. So it kind of goes backwards. If we want to find the angle, we have to use the inverse functions. Same thing works for sine and cosine. You can use inverse functions on a calculator as well. Because in this situation, we know both side lengths, and we want to find the angle. So if you type into your calculator the arctangent of the ratio 8 divided by 15, you get an angle, and it's about 62 degrees. Really, it's 61.9, and it keeps going. It's an irrational number, but we'll just say it's 62 degrees. And that tells us if we wanted to go from A to B and just take a straight shot, well, we should go at an angle of 62 degrees, and what would this be? North of west. All right, now, tomorrow we're going to continue to break down vectors using this, all right, and we're going to combine vectors, break down vectors, and all that stuff, but there's a few short devices here that I want you to see and maybe write down on your formula card before tomorrow's class. First thing, you'll see this phrase, so, ka, toa. Now, what that does, if you remember that phrase, so, ka, toa, that helps you to remember what each trig function is equal to. That means sine is equal to the opposite over the hypotenuse. Cosine is the adjacent side over the hypotenuse, and tangent of our angle is the opposite over the adjacent. So that's where the so, ka, toa comes into play. So if you are trying to remember, oh, I have the adjacent and the hypotenuse, which one is that? Well, that goes to cosine. That's the ka part. All right. Also, there's these triangles down here, and we've seen these triangles before in our force equation, in our acceleration equation, in our velocity equations. This can help you find each of these three pieces. Say I want to find the opposite. Well, if I want to find the opposite side of my triangle, then I need sine of the angle times the hypotenuse. Or I can find it over here, and I need tangent of the angle times the adjacent. If I want to find an angle, and I have the adjacent side and the hypotenuse, well, I divide those, and I know cosine of that angle is going to equal the ratio. Okay, so write these three triangles down, put them on your formula card, and have those at your disposal, and so you can use them tomorrow in our class. Once again, if you have any questions, if this is still a little confusing, go ahead, watch the video again, try to get a basic understanding before we come into class tomorrow.